about proper ways to interconnect independent sources. Some of these are more obvious than others. Some of them need Kirchhoff's laws. And the idea is that you can't connect voltage and current sources in a circuit just any old way. Remember, these are ideal sources. And some ways we could connect them on paper violate common sense and violate conservation of energy and conservation of charge, meaning they violate Kirchhoff's laws. So let's look at some examples. Let's say I have two 7-volt voltage sources. Maybe they're batteries. I don't know. They're voltage sources. And we connect them in a circuit like this. There's node A, there's node B. Now, is that okay? Well, why would you want to do that? Well, right now, let's not worry about why you might want to do that. But does it make sense? Keep in mind that having a 7-volt source here connected between nodes A and B says the voltage between node A and node B is 7 volts always, and I can't change that. Well, that's not a problem because this also says the voltage between node A and node B is 7 volts. So that's not an issue. There's nothing wrong with that. Why that might be useful we may look at later on in the course, but there's no problem there. Okay, the voltage between A and B is 7 volts, not a problem. Let's look at another possible configuration. Here's a 7-volt source and a voltage source and a 5-amp current source connected together in a single loop. There's node A, there's node B. Is there any problem with that? I don't see a problem. It's just not an issue. I've got 7 volts dropped across my 5-amp source, and I've got 5 amps of current flowing through my 7-volt source. There's not a problem there. Let's look at another case. Here I've got 2 current sources connected together in a single loop. Now this current 7-amp current source says the current flowing in this branch or this piece of wire here, this section of the circuit, is 7 amps no matter what. All right. This says the current flowing in this branch is 7 amps no matter what. That makes sense. There's not a problem. It just says I've got 7 amps flowing in this circuit. Another thing we can ask ourselves is, do these things violate Kirchhoff's laws? Well, let's do a trace from B to A to B. Kirchhoff's voltage law, using drops as positive and rises as negative, says minus 7 volts plus 7 volts equals 0. Not a problem. Kirchhoff's current law says the sum of the currents, the algebraic sum of the currents at a node is 0. Well, 7 amps is entering and 7 amps is leaving, so 7 minus 7 is 0. So that's not a problem either. And there's certainly no issues here with that. Now let's look at some other possible configurations that do have a problem. This says I've got an ideal 7-volt source connected between A and B and an ideal 5-volt source connected between A and B. Now we have a problem because this 7-volt source says the voltage between point A and B is 7 volts no matter what. But this 5-volt source says the voltage between this node A and B is 5 volts no matter what. Now the voltage between A and B cannot be 7 volts and 5 volts simultaneously. Okay, that's a problem. So what does that mean? Well, let's also check Kirchhoff's voltage law. Starting at B and going clockwise, I have minus 7 volts plus 5 volts. Oops, that doesn't equal 0. Minus 7 plus 5 equals minus 2 volts. That's a violation of Kirchhoff's voltage law and a violation of the conservation of energy. So this cannot be. It's a nonsense interconnection. And so you can't put a 7-volt source in parallel with a 5-volt source because that implies 7 equals 5, and that just doesn't exist in this universe. Okay, so it's not valid. Let's look at this case. Now I've got 2 7-volt sources again. So not a problem, right? Well, look at the polarities. This polarity and this polarity are opposite. This guy says there's 7 volts positive to minus between A and B, but this guy says there's 7 volts minus to positive between A and B. Seems like a problem. Let's try Kirchhoff's law. Minus 7 volts doesn't equal 0, it equals 14 volts. And that just can't be. So this is an invalid connection. These are ideal sources. They're not real batteries or real power supplies, they're ideal. And 7 does not equal minus 7. So you just can't do this. It's invalid. If you ever find yourself trying to do this, it's nonsense. One other example. We've got 2 current sources connected in a loop. This is a 7-amp one, this is a 5-amp one. Kirchhoff's current law says the algebraic sum of the currents at a given node are 0. Well, I've got 7 amps flowing in and 5 amps flowing out. 7 does not equal 5. It just can't be. You can't put a 7-amp source right next to a 5 amp source because it tries to say that the current flowing is 7 and 5 both, and 7 doesn't equal 5. So these are invalid sources, invalid source connections. Let's look at a similar thing with dependent sources. Here I have two voltage sources